Okay, so welcome everyone to our switching routing wireless meeting for this week. It is the 23rd of August. We're about 1 month away from the end of this course, so please be working as much as you can. We had a question about the lab and some issues with pinging. Now, one of the issues I'm going to have here, Jacob, is I can't see what you put on your PCs. But let me check your router first, and let's see what we have here. This is an inter-VLAN routing lab. So what we should end up with is sub interfaces on the router. Okay, so we got .110, encapsulation .1Q, got that. 20.1Q20, so far good. 20 network, 30 is good. 1000 native, okay. So everybody is up. So I will tell you right now, just from a cursory look at the router, it appears to me the router is correct, okay? Because see, you've got each one of your sub interfaces. You've got them associated with the correct VLAN, the .1Q VLAN, and you've got a correct IP address on it, and they are up. So I feel fairly confident that the router itself is okay. So let's investigate a little further. The next item I would always look at would be the switch, and that is, do you have on the switch the trunk link going to the router itself? So here's your VLANs, 20, 30, 999, 1000, okay. Got your default gateway set here. Got your IP address on VLAN 10, which is, okay, I can live with that, that's good. Shut all those down. Okay, all that's good. Okay, so your trunk in there, native VLANs 1000, that's correct. Allowing 10, 20, 30, 1000. All right, I'm gonna tell you, as far as routers and switches go, it is correct. You should have been able to ping if you put the right IP addresses on the, well, let me check one thing here. You put FA06 and VLAN 20. So let me go pull that lab up here. Let me pull, and I know I'm pulling it from inside of here, so just I'm gonna pull the lab. This one is actually pretty close here. So even though this is not the one from inside of NetLabs, it's pretty much the same thing. Oh, maybe it's not. Let me go get the right document. Hold on.
I guess the switch one that the interface F05 should also be trunk. That's
correct. Correct. And that's what I was looking at right there. I think. Let me do this.
I have issue with that same lab there. When I try to ping from PCB, it keeps selling fairly. So
I think I know exactly why then. Okay, and that is because
when I use the packet tracer, everything is fine. I don't know what happened to the lab.
No, that shouldn't be true. Let me go back here and look. So we're doing this configure. This is 428, correct? That's the lab we're on. 452. Okay, so right here. So let's look at this one. Let's preview the lab. Okay. So yeah, so you should be trunking on FA01 and 05 on switch 1. So let's look at switch 1. I think you forgot to trunk between switch 1 and 2. Scroll down here. So you've got your trunk. You've got your trunk going. Okay, so that's 01. So that's the trunk going to the other switch. You did not trunk to the router. See this, Jacob? You trunked right here from switch 1, FA01, going to switch 2. You forgot to turn the trunk on to 05. Because you'll see here, here's your show interface trunk. Only 01 is trunking. So let's go down here and just make sure you didn't. That is correct. So you forgot to trunk 05. That's why you could not ping at all, because you could not get to the router. The router couldn't do the inter VLAN routing because this link was not trunking between the router and switch 1. Let's go look at switch 2 and see if you set up the trunk on switch 2. Scroll down here and see. Yes. So you had your trunk. Okay. So you see now what you did? You trunked between switch 1 and switch 2. You forgot to turn your trunk on between the switch 1 and the router. If you had made this port FA05 a trunk, everything would have worked perfectly. And that's why. And I'm going to tell you why I think, Dr. Hu, you said that it worked in Packet Tracer. What is a protocol that will dynamically create trunks?
Dynamic desirable.
Right.
Oh,
DTP, dynamic trunking protocol. So maybe inside a Packet Tracer, it turned that trunk on automatically for you on 05.
I try to ping from S2 to everybody, from PCA to everybody, from S1, SR, all works except PCB, not even pin to S2.
Okay, then that would be, if I had that issue, I would look and see if it's not that you forgot to put port FA018 in the correct VLAN.
Okay, okay.
Because probably, you see here, port 018 should have been in VLAN 30.
Yes.
So you probably forgot to put this port. If you did this on NetLabs and everybody can ping everything except PCB cannot ping anything, I would check my port FA018 and make sure you remember to put it into VLAN 30. So
Okay.
that's probably what happened.
So another question here said, yeah, you see the IP address, the subnet is pretty much subnet there, right? For PCB is like a .30.3.
Right.
So then the on the port, the VLAN should be 32, right? In order to make it correct.
Correct. Exactly.
Okay.
Should be that. Yep. So you should have gone into port FA018 and put switch port mode access, switch port access VLAN 30. And that would have fixed it.
I'm sure I did it, but I don't know. Maybe it's
would you like to see? Because I can.
Yeah, you that's possible, you know.
Yeah, I can go look. I can actually go look. So let's go see if you did. Okay. Actually, you're in the other class. So let me get. I have to remember which class y'all are in, because you're in. You're
cohort
in
second. Yeah.
Yep, you're in the second class. So Dr. Hugh, let's go look here at this one. So here it is. So we can actually go to the device and we can go to switch 2.
Right.
And I can go down here and look and see if you remember to put 018 into the correct VLAN. Now this is why I love this system. Because think, even if you were doing this lab in the classroom, if I wasn't right there over your shoulder, I wouldn't be able to do this kind of thing. So there you're creating the VLANs, which is fine. Okay, putting IP addresses on. There we go. You got that. There's that. So you're giving switch port mode access. You're putting all those into your park VLAN, which is correct. Look at that. There's your problem.
Yes. Let I correct that one. If you wrote down, you can see it somewhere. I correct that problem.
Okay, so you got it there. All right, so there's that. Okay, so you still got it in VLAN 20 there. Your pings are working. Your pings are working. Still got it in VLAN, still in VLAN 20. So that one's still wrong.
Still wrong, right? Yep. Let's scroll down a bit further. Can you see?
All right, there you go. All right, so there you fixed it. Now I agree with you there.
Yeah, and I try to ping again. Just nope.
And you had put the IP address on the PC, correct?
Yes.
Okay.
Yes.
All right, let me look right here then. Let's go back up just a second, because I saw, oops, I saw your pings. All right, let's see. Let's go back up to the ping. So your ping 1011. Okay, I know exactly what it is. I think I know what it is. Nope, you got your default gateway there. Thought maybe you missed that.
Yeah.
10, 12. Interface VLAN 10. I would have to guess at this point it's something with the PC.
Okay.
Simply because,
The
because see, you can
firewall,
ping,
right?
you can ping all these. I
Mhm.
agree with you. You did have it in the wrong VLAN, but you fixed that. So
Mhm.
I would think it would have to be at that point something on that PC.
Okay.
Because when you move that over, that's correct. I mean, you are definitely correct that that's working. 018s and switch port. Yep. So that's correct.
Yeah.
And unfortunately, I don't have a way of looking at that. Now, one of the things y'all can do, if you ever want me to be able to see the PCs, you can actually take a picture of the PC. Let me show you how to do this. If you're logged in, and I've got a lab here. So let's say on this PC, you wanted to show me something, you can always click right here and do take a screenshot.
Mm-hmm.
And that will actually associate a screenshot with that lab so that I can look at it.
All right. Okay.
So you can do that. And you can say, PCB ping test, something like that. So it actually will save a screenshot for me. So if you want to do that, that may be something you start doing if you're, but that should have worked what I'm looking at there.
And actually, it doesn't ping itself.
It couldn't even ping itself.
No.
The default. You're talking about the default gateway?
I remember, right? It doesn't ping itself. I remember that.
Okay, so it couldn't even ping 127.0.0.1. Yeah, there was something very weird going on with that PC then.
Yeah.
Yeah, definitely. But the good news is, as far as the router configs are going, the router and switch configs, when you fix the port problem, it looked like it was right. So you had everything correct. The problem you had, Jacob, is you had forgot to trunk between the switch and the router. So excellent.
But by the way, I just finished the exam for the module 1 to 4. I did like a 70 something. I wonder whether you can let us to try, change the setting. Let us try a little bit more.
You should be able to take them up to 10 times.
Right now, that said, I need your approval. That seems like that.
Okay. Well, it should not have done that, but let's see, which one was it? The first one?
Yeah, first one, module 1 to 4.
I always forget which one that is. All right, here's what I'm gonna do. I'm gonna do this. Since I messed up somehow, I'm just going to bulk deactivate everything. So I'm gonna deactivate all the exams because it should have been set up to allow you to do that already. So what we have here, folks, this is a good thing for me to show you anyway. When you are actually an instructor, you will be able to create what's called an activation profile. And with that profile, you will be able to set up certain things like how long the exams are active for, the exam duration. And what I typically do, since I have done this forever, is I set it up to 90 days because it's an instructor class, 3 hours for exam duration, and I set it to let you have 10 attempts without me having to redo it. Now, you're not always going to want to do this with your students, especially if you're using these for a grade. I don't use these for your grade. So I've set an assessment profile that really uses the exams more as a learning tool than as an assessment tool. So let me go in here and change this because we know the class ends way before then. So September the 28th. And now you should be able to do all these exams up to 10 times. Okay. Sorry about that.
Thank you.
You're welcome. And I think everything else here, I am going to go ahead and turn on the course feedback for you, even though I don't think anybody is ready yet to take the actual exam, the final exam. No one's ready for that, so I'm not going to turn that on yet. The course feedback's on, And in about 2 weeks, anybody ready for the final exam to have it turned on? I don't think anybody is, but I'll turn on for 7 days just in case. The final exam can only be turned on for 7 days at a time. That is an overall rule for everything except for CyberOps Associate, which can actually be turned on for longer. But I've turned the final on, but you obviously are not expected to take that yet. So that should fix the problem, Dr. Hu. I'm sorry about that. I thought I had it set to let you do that already.
Thank you.
You're very welcome. My apologies. Okay. Any other questions before we move on to a topic that's pretty simple that we can go through quickly? And this will be a little bit shorter lecture today because this one's pretty easy. We're going to talk about DHCP, which is Dynamic Host Configuration Protocol. Some of you may know an older protocol. How many of you ever heard of a protocol called BootP? Y'all remember that old protocol? It was called BootP. It's an old protocol that was for diskless workstations. And it was designed for diskless workstations to boot up and be able to use their MAC address to go get an IP address. Well, DHCP is an extension of BootP and is a more refined version of BootP. And what it is a way for a client to get a dynamic IP address from a DHCP server. You basically have a client set up to obtain their IP address automatically. It boots up, sends out a DHCP request, a DHCP discover. By the way, I call this good old Aunt Dora. You know, she's the aunt that grabs your cheek, says when you're going to get married and have kids at your family reunions. But good old Aunt Dora, discover, offer, request, acknowledgement. Good old Aunt Dora. The router, the PC boots up, or whatever device looking for an IP address. It doesn't have to be a PC. It's any device configured to get a dynamic IP address. It sends out in a broadcast a DHCP discover and says, hey, are there any DHCP servers out there? The DHCP server sends out a DHCP offer, all right? And it can be a unicast or a broadcast, depending on the operating system and how things are working, but it sends out an offer and says, here's an IP address that you could use. That IP address is pulled out of what is called a pool of addresses on the DHCP server, or a scope. If you've ever worked with Windows, Windows calls them scopes. Here in the world of Cisco, we call them pools. But there's an offer made. Here's an IP address and options. There are options that are available with DHCP. The client says, that's a mighty fine looking IP address. Do you mind if I use it? It requests that address. And then finally, there's a DHCP ACK or acknowledgement that says, yes, you can use this request or this IP address. At that point, the host binds that IP address into its networking settings, and it has what's called a lease. Does anybody know the default lease on Windows DHCP servers? For LAN-based host, that's an important one. Does anybody remember that? Anybody in here teach Windows? Anybody ever taught Windows? It's been a long time since I taught Windows.
Yes, I do.
I am sharing my screen, right? Everybody can see my screen?
Yes, we can see us.
Okay. By default, the actual lease time is 8 days. Okay, that's the default on a Windows box. What happens with most Windows machines or most hosts is that 1/2 of their lease time, they try to renew the lease. So if it's an 8-day lease, at 4 days, they send a DHCP request to renew their lease. And if the DHCP server is there, it will acknowledgement and they will get the lease for another 8 days. And so every half of their lease time. So if you make the lease time, by the way, the default again was 8 days on a Windows box, but whatever you make the lease time, realize that 1/2 of that lease time, your clients are going to try to renew their DHCP address. We ran into a big problem here on campus in that we had our wireless DHCP scope set to have an 8-day lease time. Well, what happens when people come in with their phones, their tablets, and all these things? We actually ran out of IP addresses in the DHCP pool because they were all leased out. So what did they do? They made the lease time 4 hours, and then there wasn't a big issue at that point. So you have to be careful with your lease intervals.
What you say is default window there? What the one that you?
For Windows, it's 8 hours or 8 days, excuse me, 8 days. For a Cisco router, I cannot remember for the life of me. DHCP lease default. I'm thinking 4 hours. No, 1 day. 1 day is the. So on a DHCP pool set up by a set up using the iOS, the lease time is 24 hours or 1 day by default. So at 12 hours, the machines will try to will try to renew their lease. So if you want to configure a device to be a DHCP server, so in other words, you want this router to be a DHCP server, I'll let you in on a nasty little secret. Out in the real world, unless it's a remote office, we don't do this. If I have a choice of a machine that is a Windows machine being a DHCP server or a Cisco device being a DHCP server, my Windows box is going to be my DHCP server. Okay. But for the exam and for this, we need to know how to do this. And if you had a remote office, it's nice to be able to have this taken care of by the networking device at that office, like a router. So if you want this router to be a DHCP server, there's 3 simple steps. 1, exclude the addresses you do not want to hand out. This is extremely important because the second you make a pool, the device is going to start handing out addresses. So if you don't exclude addresses that you want to put on your static devices, they will be handed out, and you can get in a problem with devices having overlapping IP addresses. So the very first thing we do is we exclude any of the addresses we want to use for our static devices. So IP, DHCP excluded address, low address, high address. So you can put 192.168.12.1 to 192.168.12.20, and that would exclude those 20 addresses from being given to anybody with DHCP. All right. Then we create us a pool. We assign a network address to that pool. In other words, what range of addresses are we going to hand out? We can assign a default router, which in the world of scopes, if you're old school, again, Windows, it's scope option 003, which is a router, DNS server, which is scope option 006, domain name, which is 008, I believe. And then you can set the lease. And by the way, by default, the lease is 24 hours, but you can set it to what you want it to be. I would never make it infinite myself, but it is an option if for some crazy reason you wanted to do so. So if we wanted this server to be able to hand out DHCP addresses to both sides, to the 10 network and the 11 network, we would have to exclude the addresses that we do not want to be handed out. Okay. And then we would create a pool for both sides. So the first side we'd create a pool for would be the 10 side, and we would exclude these addresses. So we don't want any client to be given that via DHCP. We're going to say the network is this 10 network, so everything else can be handed out. So 10.10 to 10.253 would be able to be handed out. Here's the default router, which is just that port on gig 001, the way out. Here's the DNS server and the domain name. At this point, this PC1 could boot up and request a DHCP address and get one from R1, as long as the interface G000 was up and running and had the IP address on it. This is one of the only real items that about the only way you can troubleshoot is with show running config. So if you want to see the DHCP commands, you have to do show running config pipe section DHCP to see those in the running config or the startup config. You can see your bindings by doing show IP DHCP binding, which shows the hosts that have been given an IP address from the DHCP pool, and you can look at your statistics. But as there's no easy way to see the pool and how the pool has been configured other than looking in the running or startup config. So again, show running config section DHCP would show us our excluded. and would show us our pool that's handing out addresses. Show IP DHCP bindings will show the hosts that have been given IP addresses. Notice this one's given 1010, which was the first available one. If we look at our section here, the first available IP address that can be handed out is 10.10. The last would be 10.253. And we can also do show IP DHCP server statistics to show the DHCP discover messages that have been seen and the requests that have been sent, or actually have been given or received by the server, the DHCP request, how many pools it has, how many bindings there are. And then on the PC itself, you can do an IP config/all, and it will tell you who the DNS server is. Or not, excuse me, DNS server, who the DHCP server is. So it says it's enabled, and it will even tell you who the DHCP server is. In this case, you can see the server is the same as the gateway. So I would say this is probably the router that's handing the IP address out to this particular device. This is a very simple thing to do on a router. If for some reason you don't want this service even running, in other words, you're doing what we normally do, which is make DHCP available on your Windows machines, then you do no service DHCP. That turns off the DHCP service and will not allow it to run. That would be part of hardening the router if you are not going to run this service on it. Last but not least is a very important thing for you to know, and this is called DHCP Relay. You noticed that DHCP, real quick, what were the 4 steps of DHCP? The DHCP, what? What went out first from the host to find your DHCP servers? Remember good old Aunt Dora? So the first thing that went out was a DHCP
host advertise.
Discover.
Discover, right.
Discover. Okay. Remember, this was a broadcast to find the DHCP server. And it was created by the client, the host trying to get a DHCP address. The next thing that come out was a DHCP offer, which could be a unicast or broadcast. Sometimes it depends on the operating system and also the implementation. With an IP offer, this comes from the server. What's next? A DHCP. What was the next thing that happened?
Request.
So request. And this request is typically another broadcast. Sometimes it's a unicast, but typically it's a broadcast because at this point, the client still doesn't have a fully functioning IP address. This is from the client. And then the last one is a DHCP. Anybody?
It's a PAC or something like that. PAC.
ACK, acknowledgement.
ACK, acknowledgement.
ACK, an acknowledgement. Okay, so we'll just do an ACK. All right. And this is from the server to the client. And by the way, this is typically actually a unicast at this point. All right. But you'll notice for DHCP to work, the client has to find the server with a DHCP broadcast. Well, let's look at this network right here. This network's going to cause us all kind of trouble. We've got a Windows box over here. That's our DHCP server. Real world, that's the most common place for your DHCP servers to be. All right. It's on a Windows box or some type of server. But this client over here, PC1, is trying to get a DHCP address, and it sends out a DHCP discover. Well, when broadcasts get to routers, remember, routers do not forward broadcast by default. They drop broadcast. Broadcast domains are made by routers. So we have to have a method for this DHCP discover to get sent over to this DHCP server. That is called the relay agent, okay? Or helper address, IP helper address. So you put a helper address on the interface that you expect DHCP discover packets to come in on and tell it to forward those packets via unicast to the DHCP server. So what will happen in this network once this helper address is placed on the gig 000 is this. PC1 will send out a DHCP discover that will go across the network. it will be a broadcast. It will reach R1 and R1 will say, ooh, that's a DHCP discover. I have a helper address on gig 000 that tells me to convert that broadcast to a unicast, send it over to that host right there. And so it makes that DHCP discover into a unicast and sends it to the DHCP server. The DHCP server sends it back as a unicast to R1, then R1 broadcasts it back out. So this helper address allows R1 to be what is called a DHCP relay agent. It relays the DHCP broadcast as unicast. Very, very common. It also will automatically, with the IP helper address, send all of these UDP services to that same server. That is why you will, if you do a lot of reading on this, you'll see they've also created a command called IPDHCP. I think it's IPDHCP server that only sends DHCPs instead of all of these UDP services.
But the router can set the help address to itself, right?
Well, if the router, in this case, it's network right here.u, if this router R1 was the DHCP server, you would not need a DHCP relay agent. Because
Okay.
the DHCP request would come in from gig 000 and R1 would just respond to it. So R1 only needs a DHCP relay agent set if it needs to forward it to a different DHCP server. Now, good question. Let me show you something. Here's somewhere you would need it. Let me pull a whiteboard up. All right, let me show you this. So let's imagine this network. Let's imagine. All right, so we've got a router here. We got a router here. And we got a connection here. And we got, PCs off of a switch here. So here's our PC. Now let's imagine that the DHCP pool is here. So this is our oops. Can't type, can't write. So this is our DHCP server. Is over here on router 2. So R2 is our DHCP server. R1 is not a DHCP server. This is gig 001. This is gig 000. Gig 000 here. Okay. So we created our pools over here. And so the pool for this side is way over here. What you would have to do is on this interface right here, set the helper address to an IP address that's on R2. So right here, you do IP helper, and it would be whatever is on R2's gig 00 interface, 000 interface. Okay. That way, when this PC right here sent out a DHCP request, it would come in here. It's a broadcast. R1 would grab it. R1 would turn it into a unicast, send it over here to R2. R2 would then respond with a unicast. And then R1 would convert it back to a broadcast and send the offer like this. So you could point to another router, but if the DHCP server was actually on R1, there would be no need for a helper address, because when that DHCP request come in, or that discover come in, the router would just respond. Does that make sense?
Yes, yes.
Yes.
So the router is not going to ever set itself to be the relay IP address, the agent. It would be some other external host, be it another router or be it another server that's acting as a DHCP server.
I ask this, I just want to know what if I enter the address by accident, will that make any difference? I mean, enter itself, the address of itself. No, sometimes you just add it. Yeah. And then will that make a difference, or the rule saying you cannot do it, something like that?
It would cause problems if you were to put here in this example, if I was to not put the IP address of this DHCP server, let's say I put the IP address of gig 001, which is 192.168.10.1, that would fail. It would not work, because it would come in and would try to send it to that address, but there's no DHCP server there, so you would never get an offer.
Okay.
So it has to be set. The helper address must point to wherever your DHCP scopes are set up, wherever your pools are at. And I keep using that, and I'm sorry, because I've worked so much, but a scope, golly, talk about the inability to write. The scope equals a pool, okay, for DHCP. So DHCP scope, this is the Windows name for it. And a DHCP pool, this is the iOS or Cisco name for it. But they are the exact same thing. They're just a pool of addresses that can be handed out to DHCP clients. All right. This, folks, is very easy to do. So when we look at our lab here, so we're looking at a lab, this example is excellent because let's imagine that R1 is going to be the DHCP server. So R1, as the DHCP server, is going to have to be able to handle requests from over here off of R2. So R2 would have to send or relay it over to R2 or vice versa. I can't remember which on this lab, which one is the actual DHCP server. It's a very good lab though. Yep, okay, so R1 is going to have both DHCP scopes. And then you're going to have to take on R2 and configure R2 to relay any DHCP coming in from PCB over to R1. Okay. So I'm not going to do this lab right now, but this is a very good lab. It's a fairly long lab, but if you do this lab, you'll understand what we're talking about with our DHCP scopes and with how DHCP works on our different devices. I do suggest in this particular instance that you actually do the packet tracer first, then do the real lab, because you'll notice in the real lab, it's not giving you a lot of the commands to use because those commands are in this packet tracer. The packet tracer walks you through, handholds you, gives you all the commands to use, and then the lab says, okay, now apply those commands. And that is actually how a lot of these, the packet tracers and labs work together in the curriculum. I've also found out something else, which is pretty disturbing, and I wish it was not this way. But one thing I have found out is that they have released a new version of packet tracer, and it is 8.01. Okay, 8.01 is the newest packet tracer that's been released. If your students create a packet tracer in 8.0, or excuse me, in 8.01, and you are running 8.0, I was unable to open them. So it wasn't backwards compatible. So in other words, well, 8.0 couldn't open 8.01. 8.01 can open 8.0. So I would just suggest upgrading to this newest 8.01 version when you can. Just remember to uninstall packet tracer completely, then install packet tracer on your devices. That's the correct way to do it. All right. And here's the packet tracer showing you this one's, give it a second, it's loading here. Here's the packet tracer. And you'll notice again that this has all the commands and walks you through the commands so that, and it's a pretty complicated looking network, but you're not really doing all that much. You're just configuring a single router as a DHCP server. Remember, you exclude the addresses that you're not going to allow to be handed out first. Then you create your pools, and then you assign the pools. And then you may have to set up a relay agent. In this case, R2 is going to have all of these pools, and R1 and R3 are going to send any DHCP requests coming from their clients up to R2. This is also something that we didn't talk in the command or in the curriculum about, but this, well, it is in the curriculum, but we didn't talk about it. But this is the correct way to have an interface on a router request its IP address via DHCP. This is very common for those remote offices that are connected to like business DSL or a business cable connection. You would put in there, instead of a static IP address, you'll put IP address DHCP on that interface, and then that interface will get an IP address from the internet. So right here, I can go into gig 01, config T, int G01, oh, not 2, 1, IP address DHCP, no shut. And what you should be able to do is do show IP net brief. And you should see that it's unassigned DHCP, but it should in a little bit get an IP address. You can actually fast forward time. So you'll see that it got an IP address via DHCP. So that outside interface is configured to get one via DHCP instead of doing, we typically do an IP address and put in a static address, but we configured it to be DHCP. So even router interfaces can get DHCP addresses, which is pretty neat.
Now, what about you involve the VLANs? Was that the new DHCP address will be automatically set inside that VLAN?
You would have to have for each VLAN a DHCP pool. So you would create, that is a very good, let's go back to here. Let's do another drawing here. Imagine we got a router. Okay. We got a switch. We've got, and I'm just going to do 2 VLANs. I'm just going to do, we got a VLAN 10, and we got 2 ports in VLAN 10. We got 2 ports in VLAN 20. Okay. We've got a trunk link here going up here. All right. And so we got 2 sub interfaces. We've got gig 0.0.1.10, and we've got gig 0.0.1.20. So that's our 2 VLANs. So we're trunking right here. You agree with me? This is a trunk link.
Yes.
Okay. So what you're going to have is you're going to have a DHCP pool for VLAN 20. And you will also create another DHCP pool up here for VLAN 10. And here's what's going to happen. A PC down here on VLAN 10, when it does a DHCP discover, remember that's going to come up here and it's going to go across, and that discover is only going to come in because it's been tagged with VLAN 10. It's going to come in on VLAN on this 10, and it's going to get an IP address for VLAN 10. The client over here on VLAN 20, when it sends a DHCP discover, remember it gets tagged on VLAN 20. That comes up here, and it will get an IP address out of the pool for VLAN 20. So you have to create a pool for every VLAN. You have to create a pool for all of the sub interfaces because each one of those is a different network. And the way the router knows what to hand it out to is by looking at what particular tag trunk it comes in on. On the tag, it knows what network that's associated with, and it hands out an IP address based on that.
Now, at switch, now how does it know the host or end user is, for example, for VLAN 10 or VLAN 20? Just like a faculty go to a campus, they go to one VLAN, students go to another VLAN. Probably they use the same wireless switch somehow, right?
Right, but that, like I said, if they're using the same switch, but what happens is, remember when you set this to switch port mode access. Okay, so switch port mode access, so that makes an access switch. But then you say switch port access VLAN 20. And that tells it everything that comes in here gets tagged as part of VLAN 20. The blue VLAN is getting tagged as VLAN 10. Now, wireless, here's what happens with wireless. I think I understand what you're saying. Let's imagine we're wireless, okay? Here's a wireless access point. Okay. Typically, the wireless access point is on a separate VLAN. This may be VLAN 100. Okay. So depending on how it's set up, typically we also can trunk here. All right. And then as you connect to different SSIDs, so if you got an SSID faculty, all right, when a device out here, here's a phone or whatever, connects to faculty, it gets associated with a VLAN. So let's say this is VLAN 100. All right. VLAN 100 is allowed to go across this trunk. If there's another SSID called guest, oops, G-U-E-S-T, called guest, well, that may be associated with VLAN 200. So if another client connects to that, they will be associated with VLAN 200. So wireless works a little bit differently because you can actually tunnel out to your access point and then associate different devices with different VLANs based upon what SSID they come in on. But all that's handled at layer 2. You just tag it. All you have to do is tag it. If it comes in SSID faculty, we tag it with VLAN 100. If it comes in SSID guest, we tag it with VLAN 200. Does that make sense?
Yes.
That's
So
why.
So this SSID pretty much the username and password, right?
The SSID is the name of the network you're attaching to. So for instance, like
Domain.
whenever you set up a wireless network, you have to set up an SSID. The SSID is the group that you're a member of or the group that you're associated with on that wireless network.
The domain. Like I using it at like a SRWE, that's faculty.
Well,
but if you do at student.SRWE, that's for student.
Right, yeah. The SSID is not exactly like a domain name. The SSID can be associated to make you authenticate to a domain name.
Okay.
There's typically inside of here, and this is something we'll look at as we've got a whole section on wireless coming up. But there's inside of here the ability to do authentication using different authentication methods. But when you attach to this SSID, you're then asked to authenticate. And there's different types of authentication. .1Q authentication. There's all types of authentication. But we'll talk more about that. But that's why it's so important to understand VLANs and understand tagging and trunking. It's because those are extremely important concepts for wireless networking. Our entire networks would not work without VLANs, trunking, and the ability to do the things that you're learning how to do right now. The configurations and things you're doing right now are the basis for a large amount of what goes on your networks. Okay. So everyone, that is DHCP. It is not that difficult. Just remember good old Aunt Dora. If you ever need to remember the 4 steps of DHCP, it's good old Aunt Dora or Dora the Explorer. Discover, offer, request, acknowledgement. Those are the 4 steps. And then if you go to configure it, configure DHCP, config 1, exclude addresses first. And then 2, you're going to create your pools. Create your pools with options. And the last thing is you may need DHCP relay agents, which is also called the IP helper -address if your DHCP servers are on the other side of a router. Questions about DHCP? Our next item we're going to talk about is how IPv6 works with DHCP. We're going to look at Slack and how we have stateful address auto configuration, and then how DHCP version 6 can work. All right. we'll talk about that on Thursday. Any questions before we call it a day? Any problems with class? Any things you need me to do for you? All right, we'll stop the recording.